Hi, welcome to my channel. In previous videos, we discussed about the linear SVM classification, and soft margin classification, and also we discussed about the non-linear SVM classification, and here we discussed about the polynomial kernel, and also adding some similarity features with the help of RBF kernel, adding similarity features, and Gaussian RBF kernel. So that means the support vector machine classification performs the two types of classifications. One is it works on the two types of datasets. That is one is on a linear separable dataset, linear separable dataset, and a non-linear separable dataset. Okay, so already we discussed about the what is the meaning of linear separable dataset and non-linear separable dataset, and here we are going to discuss about the what is the completion complexity of the support vector mixed on different types of things like linear SVM classification and non-linear SVM classification. Okay, so now here the computational complexity of things are different for the linear SVM classification and as well as non-linear SVM classification. Okay, that means here SVM is divided into two parts: linear SVC and non-linear SVM classification. Okay, now so now the linear SVC class is based on the lib linear library function, which is available in the scikit-learn. Okay, that implements the optimized algorithm for the linear SVM support optimization classification. Now it does not support the kernel trick. So here that means the linear SVC classification directly works on the optimized algorithm of the linear SVM classification. It will not work on the kernel trick. Okay, there is no kernel trick is applied on the linear SVC, but it scales almost linear with the number of training instances and the number of features. So its training time complexity is roughly order of m cross n. That means m number of instances and n number of features. Based on this instances and based on the features, the time complexity is going to depend on the linear SVC classification. Now the algorithm takes longer if it requires a very high precision. So this is a controlled by the tolerance hyperparameter. Okay, the tolerance. So in the scikit-learn. Now in the most classification tasks, the default tolerance is fine. So the SVC class is based on the libSVM library. Okay, so here there are two things. One is the linear SVM, and second one is the SVC class. Okay, this is based on the kernel trick, and this is works for the non-linear classification. Okay, so which is controlled by the libSVM library function, which implement an algorithm that support the kernel trick. So here the SVC classification, it uses the concept of a kernel. Kernel is we are going to use this one, but we are not using the kernel here in the linear SVM classification. Okay, so the training time complexity is usually between the order of m square into n and the order of m cube into n. That means m number of instances and the number of features. Based on this features and the number of instances, the time complexity depends. Okay, so unfortunately this means that it gets dreadfully slow when the number of training instance gets large. That means the more number of instances are there, training instances are there, then automatically it becomes slow. Okay, this algorithm is perfect for complex, small or medium sized training sets. So whenever you are applying the kernel trick, the data set must be small or medium sized training sets. Then only it will work perfectly. So it scales well with the number of features, especially with the sparse features. So that is when each instance has a few non-zero features. At that time it works well. Okay. Now in this case, the algorithm scales roughly with the average number of non-zero features for the instances. Okay. Now here there are three types of things are there in the SVM classifications. One is linear SVC classification, stochastic gradient classifier, and the SVC classifier. So here the linear SVC classifier, the time compressed for this one is order of m cross n. It is out of core support, is not support the out of core support. It requires scaling. You have to apply the concept of standard scalar in the linear SVC classification, and also it does not support the kernel trick. You are not apply the kernel trick on the linear SVC classification. Coming to stochastic gradient classifier, the time complexity is order of m cross n, but it supports the out of core supports, and also here also require the standard scalar. Okay, that means all the data points are coming between the -2 to +2, or that means you are applying the standard scale in the form of a z equal to x minus mu by sigma. This concept is going to apply in the for all the linear SVC classification, stochastic gradient classifier, and SVC classifier. So in all the cases, we are applying the standard scalar. That is very important. And here, stochastic gradient classifier, we are not applying the kernel trick. Okay, now coming to SVC, these are the two things are very important for our model, that is linear SVC and SVC classification. The time complexity for the SVC classification, when you are using the kernel, the time complexity is very high. That means order of m square into n to the order of m cube into n. So here m is nothing but a number of instances and correspond n is nothing but a number of features. Based on these features and instances, the time comes very high in the support vector classification. So it does not support the out of core support. And whereas coming to support vector classification, it also requires the scaling required. Okay, and also here the SVCs support the kernel trick. The SVC support the kernel trick. Okay, so only SVC support the kernel, and remaining two things are not support the kernel. So that is very important. So now coming to linear SVC, it's a faster one, and coming to SVC classification, slow for the large data set, perfect for the small but complex training sets. And coming to stochastic gradient classifier, it does not converge as fast as the linear SVC, but also can be useful for the dataset that do not fit for in the memory. So these are the difference between the support vector classification in different types of things are there, linear SVC and the support vector classification. So in the coming video, I am going to explain them with one SVC classification for the iris flower datasets. So thank you for watching our video. If you like the video, please subscribe my channel. Thank you.